Hello, everybody, and welcome to today's presentation, AI-Powered Performance Monitoring, the Compass for Your CI/CD Journey, brought to you by Instana. I'd like to introduce you to our presenters. Don Brewer started his career 12 years ago and has learned by doing in-development infrastructure, architecture, and operation roles in both enterprise corporations and startups. He immediately recognized a common thread in each role that allowed him to focus on enabling teams and companies to succeed through standardization, simplification, and automation. In his current role, Don operates with one simple principle: to automate himself out of a job.
Hey, this is Don Bauer with Franklin American Mortgage, and I'm excited to be here today.
Our other presenter today is Pablo, with over 25 years of broad experience in IT. Instana co-founder Pablo Barron is the company's CTO. Prior to Instana, Pablo has worked as an enterprise architect and an engineering lead in companies of various sizes and markets, including Sixt and Unicredit. He has also helped multiple startups deliver successful technical products from the ground up, which includes managing the internet solution delivery business in the early days of e-commerce. As a consultant, Pablo has helped enterprises such as Deutsche Bank, BMW, ING, DIBA, and Fiducia make strategic technology moves, especially big data implementation.
Hi, everybody. Thanks for attending.
And with that, I'll turn things over to Don to begin the presentation.
All right, well, thank you for that. So hello, like I said, a little bit about me. My name is Don Bauer. My Twitter handle is DevOps Don. I am currently the lead DevOps engineer for Franklin American Mortgage Company, headquartered here in Franklin, Tennessee, which is just outside of Nashville. Within Nashville here, I am a Docker community leader. I've held positions such as systems engineer, software developer, infrastructure engineer, cloud engineer, application architect, and now, of course, DevOps engineer. And the industries that I've been involved with in my professional career include communications, agriculture, construction, and now finance. So what I wanted to cover first here was how we started our DevOps journey here at Franklin American Mortgage. And part of that for us was kind of just defining what DevOps is. DevOps means something different to just about every organization or every person. And it is far more than just automating simple tasks. For us, DevOps was about breaking down the barriers and removing teams from their silos through active communication and collaboration. We wanted developers to be thinking about operations when they were building their applications or building out the next big thing. And on the opposite side, we wanted our operations engineers to be thinking about the developers when they're completing their work. So that's how we were hoping to break down the walls and the barriers by getting these two teams talking to each other, and DevOps as a teams kind of existed as that liaison, so to speak, between the two teams. I personally feel that the goal of a DevOps team is to enable the success of our customers. And we might be working for a customer or working for a company where our customers are people getting mortgages for buying houses. But within the organization, as the DevOps team, our customers are going to be operations and developers. And our success is measured by the success that we can enable for those teams. I do truly feel, like it was said in my introduction, that as a DevOps engineer, my job is to automate myself out of a job. But luckily for any other DevOps engineers that might be here on the call, technology is moving so fast that I think we're going to be pretty safe for the foreseeable future here. So when we started going down this path at Franklin American, we had to define our vision. So our DevOps vision started with one simple foundation, and that foundation was visibility. And then beyond that, we have some pillars that kind of make up the rest of our process. And those pillars are simplification, standardization, and experimentation. And these pillars have, they started as part of our vision, and they've now become part of our culture. And they drive the decisions that we make when we're moving forward with any project within our IT ecosystem. And the culture surrounding them is now spreading like wildfire across the rest of the organization. So the first thing, like I said, the foundation that I wanted to touch on here is visibility. So there should never be the question of what are you guys doing over there? But visibility is actually much more than that. Visibility across teams and departments enables a culture where developers and engineers can learn from each other's successes and failures. It fosters an environment for cross-functional, personal, and professional growth. This helps to break down the silos and the barriers that traditionally separate teams, and it helps alleviate the finger pointing, the he said, she said, and just throwing problems across the wall. As we've evolved as a company, we're integrating visibility and transparency into all of the processes that we're employing, not just those limited to IT and our DevOps success. So given this call, the first thing I wanted to touch on with that is monitoring. So when I was an engineer with Charter Communications, my old boss, Jeff Gutterman, used to tell me, if you can't monitor it, then it never happened. And this is a tenet I've continued to live by, and we've adopted and taken seriously at Franklin American Mortgage. The one big important thing there, and it took me a little bit to figure this out, is it's kind of comes back to that if a tree falls in the woods analogy. Analogy might not be the right word, but if a MySQL database fails in production but no monitorings around it, did it really happen? Your customers and your users should never be the people telling you that something's down. And this comes back to monitoring is hard. And more importantly, root cause analysis is hard. Your website is down. You got to figure out why. And so, this is one of the key pieces that we brought in when we started building out and acting upon these pillars of success that we had set up for ourselves. The one big thing we ran into when we were evaluating solutions is, the installation and maintenance of a monitoring solution is hard, just like everything else on this slide. None of it's simple, and that can be problematic, especially for smaller organizations that are starting out from the ground up. In our case, we were moving from a monolithic architecture to a microservice architecture. And with the monolithic architecture, it was pretty easy. We could install an agent on, the 3 hosts that might be involved in a 3-tiered architecture, and we got most of what we needed from that. But as we moved to a microservice-driven architecture, the complexity involved in not only monitoring but maintaining and supporting those solutions moving forward, increased significantly, and it just gets more and more complicated over time. So I'll touch here in just a little bit on how Instana helped us with that, but this was one of the things that we approached while we were going through our journey here. We're still happy with where we ended up, and I would recommend this architecture for just about everybody. But like I said, I'll touch on that here more in a minute. So the next pillar we addressed was simplification. Developers, and in my personal opinion, good developers are lazy. And I'm sure we're all familiar with the terms, KISS and DRY. Keep it simple, stupid, and don't repeat yourself. Good developers will create services and interfaces using repeatable patterns. And when we started putting all this together, our first question was, why should DevOps be any different? So first thing, and this is simple, automate all the things, all the remedial tasks, all the simple maintenance items, things like patches. We wanted to make sure to get all of those automated so our developers and our engineers and our operations personnel could spend their time thinking about the next thing they were going to do and not focusing on maintaining what we're doing now. The next thing was making the tools fade into the background. So tools should be easy to use, they should be intuitive, and whether we're building them, providing them, supporting them, we wanted to make sure that the tools did not get in the way as we were going through this journey and developing our new software, our next generation platform. The next thing we focused on was simplifying, was centralizing whatever we could. So, making a central repository for things like deployment scripts, things like standards, documentation, how we handle support processes, things like that, and I'll cover that more here in just a sec. And the other big thing was using community adopted standards where you can. You can't always do that, but when you can, it's simpler for your customers to integrate with you and vice versa. And this one's the hardest one for anybody who's got an engineering background, because we all want to reinvent the wheel. But don't reinvent the wheel. The wheel's just fine. As easy as it is to look at something and say, hey, I think I can make that better, what we forget most of the time is that, well, yeah, if you make it better and you do this thing, now you've got to support that thing, you've got to continue to maintain that throughout time, and you end up incurring more debt that way. After we approached simplification, the next move was to move to standardization. And like the slide says here, naming things is hard. Consistency across an organization, across a platform, across a set of software, and especially when you talk about things like microservices, is incredibly important. So we wanted to address that immediately. So we started simply with standardized project layouts. Those are as simple as just deciding on a directory structure that could be applied across code bases, across languages. So when we were building out our CI/CD processes, any of the automated jobs that we built to support that would know exactly where to look for what files it needed to do whatever thing it was being asked to do. The other big thing was standardizing interfaces for communication across apps. And this is something that's going to vary from organization to organization. So whether you're using REST APIs, socket-based interfaces, web services that are using something like WebSockets, you want to make sure that whatever you're using to communicate back and forth between those services are using some sort of standardized interface or envelope for their communications. The other thing is we wanted consistent and centralized build and deploy scripts. We didn't want to maintain build scripts and deploy scripts across these 300 projects within the organization. So we centralized those into one repository that runs as a Docker container during the CI/CD process, whether it's building or deploying. And those are throwaway containers. They load up once, they run what they're supposed to do. When they're done, they shut down, and that's it. So we don't have to bloat our projects with these build scripts, with these deploy scripts, and everything centralized. The other big thing with standardization is something as simple as metadata. And this is something that I feel like a lot of organizations ignore or just overlook. Metadata is incredibly important, especially if you're moving towards a microservice-based architecture and you're doing something like containerization. Your images allow you to attach labels that can describe them. And if you're building your images as part of your CI/CD process, you can inject those labels at build time that can link it back to a specific commit, what repo it came from, what developer committed the change, who deployed it. And when you actually get to the deployment level, you have another opportunity to inject even more metadata there. So when things do end up in some sort of monitoring solution or logging solution, anything that's gathering metrics, that just gives you more and more points to group and collate your metrics with. The biggest benefit that we've seen from this is it simplifies developer onboarding and ramp up time. So the process is streamlined because everything's standard across all the projects. So whether somebody's coming in to work on a Node project or a Java project or a .NET project, all this stuff surrounding how we deploy whatever it is they're about to build is standardized, and it's the same across everything in the ecosystem. So once we got through this with visibility, simplification, and standardization, we were able to move on to our final pillar, which is that of experimentation. And my favorite thing here is the quote at the bottom of the slide. Being a mad scientist is way more fun than being a mad engineer. So with experimentation, there was one very, very specific thing we wanted to focus on, and that is the ability to fail fearlessly. Failure is one of the most important tools for any engineer or developer, and it's what separates the good engineers and developers from the bad ones. And again, this is my opinion, but failure is how we as human beings learn best. So we wanted to enable the ability to fail fearlessly, and more importantly, well, not necessarily more importantly, but we wanted to be able to fail fast. And with that comes the ability to fail often. We want our developers and engineers trying new things. We want them trying new things as often as they possibly can. And we want them always looking ahead. We don't want them to be worried about if this thing doesn't work, what are we going to do? We wasted all this time. We've set all these other three pillars up to enable experimentation quickly, efficiently, and not having to spend weeks or months on testing this new thing or trying this new technology. They might spend hours or days on it instead. We want our developers to take chances trying new things. So this kind of covered at a very high level the stuff we put together to get our DevOps vision rolled out to the company, to get our CI/CD processes set up around our next generation line of services. But I really haven't touched too much on our stack. So for how we're deploying our things, how we're building our things, this is just a basic overview of the most important pieces of our stack. So we are using Docker for our containerized microservices. And the beauty of that is it doesn't matter what language the microservice is written in, because we've already defined the interfaces and the communication bus and everything else around that. For service A to talk to service B, they're all going to follow the same pattern. In the middle there, we are using GitLab, and GitLab's handling our continuous integration processes using GitLab CI. And then as far as the cluster and our ecosystem goes, we're using Elk to gather and correlate the logs from our entire cluster in one central location. And then we've got Instana monitoring the entire ecosystem, which has made it incredibly simple, but I'm going to let Pablo speak to all that here in just a minute. As far as our services, I mean, you name it, we're using it. We've got services that are written in .NET, Perl, Ruby, Golang, Spring Boot, Python, Java, PHP, Node.js, and I'm sure there's probably 5 or 6 more that I'm leaving out of this. But the big thing there was, we needed a way to monitor and maintain all these things, despite that some developers are only going to be fluent in maybe one or two of these things. Everything was centralized and standardized in such a way that doesn't matter, because by the time it's deployed on the platform, it's a container. And that's really where Instana actually helped us out. So we brought them in about halfway through this journey, after having already had POCs with several other monitoring companies, and we actually had a contract with a different one when we brought them in, and they were difficult and cumbersome to maintain, and quite frankly, they didn't do what they needed for us. So what you're seeing right here, this screenshot, and I'm sure Pablo here is going to have more screenshots and descriptions of what their platform can do. But what you're seeing here is day one, when we said, hey, let's give Instana a shot. We installed their agent on our nodes and went to the UI, and inside of about a minute and a half, we got this entire view of our entire ecosystem. So this is just our production ecosystem. If I did the full view, it wouldn't fit in the slide. But within about a minute and a half, no configuration necessary. This is what we were able to get, and it's really helped enable us to move forward with what we wanted to do. And the next big thing about that was really helpful for us was their application map view, which again I'm sure Pablo's going to cover here in just a minute. But this gives us real-time feedback into what's going on within the ecosystem, and then from here we can jump into traces, we can jump into monitoring dashboards, things like that. And it's really simplified things like root cause analysis and troubleshooting. So before I turn it over to Pablo, I did want to just provide a couple stats, and just since we've concluded our journey here, we have one production cluster that's currently running about 20 environments, and a number of those environments are prod. They're just segmented by responsibility. And within that cluster, we're running roughly 300 services, just over 1,000 containers. And with the processes that we set up using the standardization, simplification, and experimentation principles that we've been putting together based on the foundation of visibility, we're now able to run roughly 200 or more deployments daily, and that's an average day for us anymore, which is far better than what I had been used to in the other industries and places I'd worked, where it might have been one or two a week. So with that, normally I would open up for questions, but I'm going to just go ahead and hand it off to Pablo, because I believe we are saving questions for the end of this. So thank you for your time, and I appreciate that. And with that, I will let Pablo from Instana here take over.
Thank you very much, Don. That's great numbers. This is a great approach. You guys definitely rule. We love you. Love to have you as customers, a happy customer. So my name is Pablo Barron. I'm co-founder and CTO of Instana. And I want to emphasize my part of the presentation of just a few aspects of what is necessary actually to make customers like Don happy with our solution, and what is definitely needed in the APM territory that we cover as a product. So who we are, we founded the company with a couple of APM experts, and we have plenty of APM experts on board in different areas, helping us shape this product and make it successful to the customers. And from the beginning, we've built for DevOps. We've built for modern architectures, modern approaches, effectively around all of the concepts of continuous delivery and understanding of change implications, and really almost zero configuration, et cetera, because we truly believe that everything in the IT world is going into this direction. And I will explain why and how we address that. We operate globally. We have hundreds of customers in dozens of countries already, and we are a pretty new player. And we built this robot that you see on the right side that I will explain in more detail how this guy can help you build and maintain the organization Don described. So a quick overview of how we see the business IT alignment these days with everything around digital transformation. So the business needs to have their stuff as quick as possible in the market. They want to verify, they want to test ideas, et cetera, et cetera. Everything is quick. There is competition everywhere for every single industry, for every single player in every single industry. So we need to be fast and fast and fast. And IT itself has reacted on it with a number of approaches that all together build an organizational system to effectively support this business, starting with the Agile development over CI/CD, which is an extremely important part of the whole story, and I want to emphasize particularly on this one. But it's also about how the modern solutions are being architected to reduce delivery impact. It's just the small pieces that Don also described. And also embracing the cloud, effectively utilizing as much SaaS as possible and utilizing, the infrastructure and services that you rent from particularly public cloud providers, just to have elasticity going. We pack everything in container not to underutilize the pretty expensive virtual hardware or real hardware. And you still need to maintain the big picture. So here's where the container orchestration like Kubernetes comes into play. So IT is becoming real fast, and it's not yet there. It is, but the question is, how fast is fast? There is a price that we're paying for this, and this is definitely complexity. It is challenges. What is happening is that since we split everything in smaller pieces, give responsibilities to many, many teams that are continuously pushing their artifacts, the code into production to verify ideas or to simply fix bugs and whatsoever. The time to market is very short. It's many hands and many contributors. It's many different artifacts. It's way more, as you've seen on slides from Don, that they have migrated from a monolithic application into microservice-based application. And you've seen on this graphic that there's much more pieces interconnected. So code is continuously changing. As you've seen, this customer is doing over 200 deployments a day. The price you're paying for that is complexity. And what we like to say is that with many artifacts and versions and contributors with many hands, this leads to chaos. Chaos is not necessarily a bad thing. If the chaos is controlled, it's actually a great thing, because that's where you can implement what Don has spoken about: experiment, try out things early, etc., etc. Just to give you a real quick overview, just on a few hosts of some of the environments we're monitoring. This is how the logical layer can explode. It's just too many pieces just talking to each other, connected to each other. This is a pure explosion, even in a very small environment, infrastructure-wise. So how do you beat complexity? You actually need a robot. I mean, because what you can manage, what you can handle with humans in a small environment that perfectly works, in a large environment with a lot of changes going on, you need to automate as much as possible. So here's how we structure that. We are continuously discovering, Instana, the product itself, is continuously discovering every single piece of technology, every single logical component that we need to monitor, where we are installed on. You don't need any configuration for that. There is just a few very small exceptions where it's definitely needed, but the absolute majority is just zero configuration. And you just roll out our agent, and there you go. As Don said, 1.5 minutes until almost full visibility. We also understand a lot of technologies. We're automatically attached to a lot of technologies. We really see them. And once the data is flowing, we have 1 second resolution for all our metrics, and we have immediate collection of traces in the field, which gives us the ability to visualize the problems instantly, and also everything that I will speak about in the area of artificial intelligence, how we see it. we have very precise data to operate upon. So it's not sampled if it's not necessary. It is pretty raw. And we have this robot, we call him Stan, that sits there as a part of your team and helps you beat complexity just on a high scale. So just a quick idea here. As you see, we're moving from the right to the left. We are approaching everything around continuous delivery. We're just approaching very short time to market. We package our things in the very small packages that are, so the dependencies between them are there at runtime, but at the development time, they are literally zero, and everybody can push themselves. So we're moving towards a very high velocity of delivery, but at the cost of increased operational complexity, because this is like, how you keep the energy. Somewhere there is a cost to pay. So what the whole story around continuous delivery is that you should be trying to automate as much as possible. I like what Don said. He's trying to automate himself out of the picture, which is a great approach because humans make errors. Human brain is a great computer, but it is limited in how much stuff it can see in parallel, at least consciously. So while we are automating everything around delivery, there is one gap, which is the monitoring part of the whole story. Like, how does stuff behave after I changed my through the new delivery? Is there a change? This part is so far left to humans, at least before Instana, because this is our goal. Our message is you should not be doing monitoring by hand manually. You should automate as much as possible out of it. And then you have the whole automation story going from as much as possible tested, as much as possible delivered, as much as possible monitored. We speak of the so-called uncertainty determination quadrant, which is very important for the monitoring itself, because there are different things on different levels that you might know, might not know, or might not be expecting, etc. So we speak of known knowns, unknown knowns, known unknowns, and unknown unknowns. I will use them as a reference on the further slides. So if we look into how classic APM worked, which is a great foundation, it is a great concept, it definitely is needed for the monitoring post delivery. What it gives you as a classic APM toolset, it gives you a quick understanding of the known unknowns. It will help you solve very quickly what you already know, but it's all mostly around the code. The story is larger. It's not only the code. It is how the code behaves in a particular environment, on particular infrastructure, in a particular cloud account, etc., etc. So you're gonna need to combine all these things. And the next step that is being approached in the monitoring space is to control this by rules. So I'm sure that everybody is doing this, has been doing this, like configure your own thresholds, etc., etc. This is a very neat instrument when the change rate is not high enough. When the change rate is like, as we have seen, at over 200 deployments a day, what can really change with every single piece of code that you push into production, the whole picture actually can change. So you will have to continuously adjust your rules and make yourself as a human being inevitable part of the monitoring solution, because you on one side have the understanding of what's going on. On the other side, you need to adjust this as you go. So you keep yourself busy. You cannot really automate yourself out of the picture. But this approach is very powerful if you can manage to kind of adjust that, especially when it's about the known knowns, about catching the stuff that you already know and you're prepared for. The further approach is to introduce statistics, and different tools on the market are doing just that, focusing on this. The statistical approach is giving you the kind of rudimentary prediction ability of what's going on. But when you look at the right side, this is a very famous quartered. So all of these data sets have exactly the same mean statistically, which means that when you just operate on these numbers, you lose the detail, the level of the detail. You see that some of them have obvious outliers, and you would not catch them with regular statistics. Well, you can do much more with percentiles, of course, but this is again adjusting, manually adjusting, experimenting, etc., etc. Also, statistics, if naively applied, will assume some sort of data distribution not learned. So you would assume kind of a bell curve over the day, which is not really the case with very many setups that we are seeing. But statistics goes into the right direction, definitely, and it helps identify the so-called unknown knowns. And it's a great tool in a tool set. But what you definitely need here is kind of more semantics. So pure statistics would operate on pure numbers without any further reasoning, how things are interconnected, how they depend on each other. Just to give a very simple example, a service A can be broken because service B is unavailable because it cannot talk to Elasticsearch, because Elasticsearch is broken because the majority of the nodes doesn't have disk space. So this is what we have built in the product, the semantics that gives the robot the ability to reason about what's going on and to explain these dependencies. And we are continuously maintaining them, of course, because whenever the picture changes, whenever connection change, we just keep them updated and updated and updated and look at the current situation as we see it. The next part I want to touch is the machine learning. It is more sophisticated approach. I mean, it is mathematically kind of in the neighborhood of statistics, of course, but we don't want to open this discussion. It goes beyond that. It also can apply some knowledge-based concepts like rules, etc. What is neat about machine learning, it can really identify or adjust for unknown knowns and identify the unknown unknowns. But the price for that you're paying is that the model you're operating your machine learning algorithms on needs to be carefully selected. It is very hard to automatically learn a model or train a model. You just need to do a lot of research with data scientists effectively to understand the domain and understand the implications of the numbers on each other, just to give them a meaning. Otherwise, you will be ending up in the situation that I typically say that you will find out that the color of pants people wear somewhere in the North Russia perfectly correlates with the amount of rain in the winter in Australia. The question is, does that make sense? Without effective domain knowledge, without the semantics that I just mentioned, it doesn't make too much sense. So you cannot really rely on automation of monitoring just by numbers, just by trained algorithms. So how do we see AI to support this continuous change to really support the automation of monitoring story? It is a combination of all of the three approaches that I mentioned. Some of the cases can be really caught by basic knowledge, by more sophisticated statistics, by machine learning, but it's all about semantics underneath. The interesting part about that is once you have this implemented, and this is what Instana provides, this robot in your team will not ask you for a raise. They will not ask you for days off, etc. They will be just sitting around and listening to everything that flies by, that they also automatically discover, and pretty much behave as if it would be somebody giving you hints from your team itself, but on a much larger scale. So the AI can automate in this territory the issue recognition. That's what you see on the right side. The reasoning, as I explained. Selection of the components for troubleshooting. If you have so much stuff going on, but this is just a particular area where it's broken, you need the focus, and this is what we give with our tool. We keep you focused during the period of your root cause analysis. We give you as many hints as possible to simplify the root cause analysis for you, just 2 seconds to minutes, and from there you can really roll back and see what you need to change in your code, etc. Also, giving recommendations is a very important part, like how to fix configuration problems, etc., etc. There's plenty of knowledge that we have built into our robot because For example, messaging systems like Kafka behave the same in 99.5% of all setups. And this little difference is just what you bring with your own solution. That's where we are applying different approaches. Also detecting complex anomalies and giving you reliable forecasts on how your system is going to behave once we see how it has changed with the recent deployment. So we say that having AI is extremely important for APM automation. And the APM automation is extremely important to really close the circle of what you do with your DevOps organization and what you do post continuous delivery as you go. Just to summarize that, what the robot can do, they do automatic discovery, as I said, also observation of changes, continuous observation, immediate analysis of the data points flying in, including traces, like less structured data, including metrics that are more structured data. It gives you actionable hints. It has a short and a long-term memory. I don't like the analogy with the brain, but it's necessary to see the problems on a larger time frame and on a smaller time frame. It just depends on the semantics of the particular time series, for example. And we also support multiple data sources. So the message here is ultimately monitoring the world of modern dynamic applications requires AI to work properly. And as I said, it is complementary to your DevOps and CI/CD adventure. Another summary is how we structure this in our pillars, 6 pillars of application management. This is how we see the whole territory these days. You need the auto discovery, you need a high fidelity visibility, 1-second resolution in our case, a sophisticated application model with semantics that is also extendable to whatever new layer of deployment or infrastructure people come up with after the orchestration. That is kind of the, well, I mean, meshes are coming, etc., etc. So people keep adding layers and layers and layers. And we have a very adjustable model to adapt to that continuously. We're cloud native, and we built our own solution to best support the solutions we're monitoring. So we architected it the same way how we monitor, like the environments that we're monitoring. And there is the robot that would predict incidents, point you at incidents, give you sufficient hints for very quick root cause analysis, and hopefully get you to problem resolution. That's it from our side. We're open for questions, I think.
All right, thanks. Thank you, Pablo and Don, for 2 completely awesome presentations. I'm a geek with this stuff. I eat it up. I'm sure a lot of the attendees like it too. In fact, we do have a few questions that have popped up already. The first one is for you, Don. How long did it take your team from the initiation of the DevOps project itself to start seeing changes in operations, and what were those first changes you saw?
So that's a fun question to answer. So from start to finish, and I did cover this when I spoke at DockerCon last month. The fun thing about this is we really started building and promoting this in November of last year. So I mean that's 7 months, and the results were almost immediate. And what's been really interesting about that is as we've gotten better at it, as we've got this new paradigm, new way of doing things pushed out across our innovation team, rather than getting a top-down directive that's getting pushed out to the rest of the company saying, hey, here's how you guys need to do things now. We've got these other engineering teams, these other development teams coming to us and saying, hey, we want to do that thing that you guys are doing because you're able to move a lot faster and you don't seem to be burdened by the same problems we have. So that's made adoption a lot faster. But as far as like the first change that we saw, you know, the first result of starting to implement this was as we started hiring new developers to expand the team to actually take everything that we'd put together where we wanted to go. With the simplification and standardization of our processes, of our code bases, of our interfaces, bringing in a new developer, they would only need 1 to 2 days to, you know, do their normal stuff with HR and get their machines up and running, but also kind of learn what we were doing, how we were doing it. And they had all the documentation available. So within, you know, their first 2 days, by the third day, they're providing value. They're you know, adding to what we're trying to do. They're not encumbered by learning the nuances that separate, you know, how this service works from that service and things like that. So I mean, that was easily the first thing that we saw. But I mean, the velocity at which everything's moving now, it's, you know, it's the whole process has just made all that faster and easier to understand.
That was a fun answer. I like that answer. Pablo, I have one for you about Instana. The question is, how does the robot, what kinds of things does the robot do? I guess I'm trying to paraphrase the question here. What kinds of things does the robot do to help enable the automation pieces of the Instana solution?
Yeah, that's a great question. So the robot itself, as I tried to explain in the presentation, implements the 3 aspects that we see necessary to really call it artificial intelligence around APM, which is it comes with plenty of pre-built knowledge for all of the different problems and configuration issues around different technologies. We are looking with many different statistical algorithms into the behavior of physical and logical KPIs. So to give you an example for the logical KPIs, it's the calls per second, it's the error rate, it is latency, and it is a number of instances of a service, which is extremely important in a scheduled environment. So we have all different approaches there to understand how any of those can be broken. But there is also plenty of different KPIs and different infrastructure components we're looking into. Now, what the robot does then, and I mean, it's not only statistics, there's plenty of machine learning as well, where we try to train on a stream or on a longer time frame, etc., etc. It's a whole list of algorithms. But the algorithms are less important. What we really call the robot in this case is that it allows you to, so it gives you a special object once your public service KPI is broken. It gives you a special object telling you why it might be broken, what is the reason for that. We use our own semantics, the connections between all the tiny pieces to explain what's going on. And I gave this example with a very simple example with a service that cannot talk to the other service because the elastic is broken because of some of the physics underneath. And we look through all of them. So we apply all of the knowledge and algorithms on different metrics and you know, also metadata in some cases like configuration, etc. For every single piece of technology. To give you a complex example of how a path in the graph, that's how I call it, the dynamic graph, how a path can look like, we speak of a service running like on 16 Spring Boot applications. Any of this is itself a JVM. It is itself a Linux process inside of a container on a host in a AZ in a data. Plus, there is a parallel path that goes into the Kubernetes space then, because it is part of a pod, of a deployment in a cluster, etc., etc., etc. So we look at all that, apply all these different algorithms and knowledge pieces on all of the smaller pieces, then we bring them together in terms of reasoning, because we have the explanation pre-built in, like to tell you that A can be broken because of B, because of C, because of D, and you get a real condensed picture on what's going on during your incident instead of having to look into. So you know that when this happens, you need to look into this service. This approach scales in a smaller team, in a smaller environment. This approach doesn't scale when you have gazillions of different microservices interoperating, developed by many different hands. So the root cause analysis in this situation is extremely hard. So that's the approach we took for our robot to simplify and almost automate the root cause analysis.
Thank you, Pablo. Hey, Don, I wonder, do you have any experiences that you could share what you've seen the robot do to help you guys automate?
Yeah, actually, I do, and this is one of the things that every time I talk to somebody about Instana, that I bring up is, we've had several crises that Instana's helped us solve, or in a lot of cases, Instana's helped us prevent. So, one of the simpler ones is, things like infrastructure monitoring. So when we brought Instana in, we were more or less using it for its APM layer, but it's also monitoring the networks that our hosts are connected to, the disks that are mounted on those hosts, and it was able to quickly identify, hey, this disk is filling up faster than you're purging data off of it, and if you do nothing, in 4 days, it's going to be full, and you're going to have an outage. And we've had that happen, several times on our stack as it's running now. So we were able to set up a notification surrounding that, pointed to a webhook we have listening on our side. Now, when that's triggered, we automatically run a cleanup script on that node, which would normally happen when it's rebooted, but that might only happen once a month. And so we were able to automate remediation of a problem that hasn't yet occurred using the AI that they've got put together behind this. And then when we have had issues that have affected our production systems, we have a web interface that has gone down, and customers can no longer access whatever service it is. Instead of going in and clicking through monitoring screens trying to figure out, okay, well, this thing's okay, this thing's not, what's this guy talking to, we logged into Instana and it said, hey, here's the issue, and it was really clear about it. It said, hey, this service is down, but this is why we think it's down. And it was 3 services away. Our Redis database ran into some sort of sharding issue, and it probably would have taken us an hour to get to that conclusion. And all we had to do to land there was click into Instana, click on the incident, and it was able to immediately say, hey, this is the symptom, but we think this is the cause because this happened, within the same time. I mean, there's 3 seconds before the data that gets picked up and analyzed by Instana is available to you. And so within 3 seconds, we knew there was an issue, and we knew exactly where to look to, fix it. And I mean, that's been huge. It's one thing to put stuff like that in a slide deck or on your marketing site or anything like that, but in practice, we've actually seen this robot work. And with the alerts and stuff it's thrown, we've been able to automate a lot of the the maintenance tasks that are associated with it. But it's also helped us tremendously in actual issues that are affecting actual customers.
You're making me cry, Don. Thank you for that great description. Fantastic, phenomenal advertisement for Instana. I think I'm going to turn it over to you, Billy, and say, let's go ahead and say thank you to the presenters and the attendees.
Great. It was a great presentation, guys. I'd like to thank all our presenters today, Don and Pablo, for a great presentation. I'd also like to thank today's sponsor, Instana, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who showed up today. We hope you learned something new that'll help you in your developer career. Have a great day, and we'll see you next time.